Let's take a look at how we would use significant figures with this example of rebar. Now, one way to measure the volume of something is to put it inside water or another liquid and look at the change in the volume of the liquid. And the change in the volume of the liquid represents the volume of the rebar. So you start out here and you have what looks like about 13.5 milliliters. So down here it's written 13.5 milliliters. You put the rebar in and it goes up to 22 and about 4/10. Okay, that's the best you can do. So you subtract these two, and that means the volume of the rebar is 8.9 milliliters. Now, from basic science, you might remember we talked about density, and density represents mass divided by volume. Now, we measured the mass of this rebar, and we had a very good scale. And this scale read the mass out as 69.658 grams. So it was a very accurate scale, okay? The uncertainty here was all the way out to the thousandths place compared to the tenths place with the measure of the volume. So we put this calculation in, and what comes out of our calculator is written right here. But how certain are we of any of these numbers? Okay, we can only be as certain as we are of the least certain number, and the least certain number is this 9. Remember? Because these were the significant figures here, so our answer can only have to the tenths place because that's the last certainty. So we have to eliminate the rest of these numbers right here, starting with the 2. And in this case, because this is less than 5, you round down. And so the answer is, to the appropriate amount of significant figures, is 7.8 grams per milliliter. We can do some more practice on this in class. Here's another example. Again, you start out, and this looks like about 17.2, give or take, and this is 17.1, it looks like 19.8. And the mass here, again, we have our excellent scale, 51.842. So you know that our answer is going to have to stop at the tenths place. So first of all, we measure the volume, 19.8 minus 17.1, which is going to be 2.7. And then we do the density, which is the mass divided by that volume, and we get this great big number out of our calculator. But we can go no farther than the tenths place, and since this is a 0, we just drop the rest. So the answer is 19.2 grams per milliliter. Now there's a difference between accuracy and precision. There was a movie I watched one time, and the guy kept saying it's all about precision. It's all about precision. But I wasn't completely certain that he actually knew what he was talking about, given what he was talking about. So what is the difference between accuracy and precision? Well, A shows something that's both accurate and precise. An accurate and precise measurement, or an accurate and precise estimate, or an accurate and precise anything, are both accurate in that they're close to the correct answer, or the true answer, and they're precise in that they're close to each other on the scale. So accuracy is a measure of how close you are to the truth, or in this case, how close you are to the bullseye. Precision, on the other hand, is how close each measurement or each attempt is to each other. Therefore, you can have something that's precise but not accurate, and that's shown in B. All of these arrows, all these measurements are close to each other, but they're not very close to the middle, not very close to the bullseye, so they're precise, but they're not accurate. This would be an instrument that is not calibrated properly. It's working right, but it's not calibrated properly, so it gives you precise answers, but not accurate answers. And then you have a really bad device shown on C, or a bad shot, whose estimates are both inaccurate and imprecise. So they're far apart from each other. They don't have the same precision, but they're also far from the bullseye, so they're not very accurate. So you have four archers here: W, X, Y, and Z. You can stop the tape at each one to describe each one. Archer W, how would you describe him? Archer W would be described as probably both accurate and precise. Archer X, how would you describe him? He would be described as precise but not accurate. Archer Y, how would you describe him? Well, he is the most inaccurate and the most imprecise. And lastly, Archer Z, he's a little more accurate, but he has some trouble with precision. Now we'll finish up speaking about temperature conversions. And these are the real calculations you're going to have to do with this week's lesson. Temperature conversions, there are three temperature scales shown here. On the left is Fahrenheit, on the right, in the middle is Celsius, on the right is Kelvin. So the Fahrenheit scale is the one that you're used to, in which 32 degrees represents the freezing point and 212 represents the boiling point. So there are 180 degrees of Fahrenheit between freezing and boiling. In Celsius, 0 degrees represents freezing, and 100 represents boiling. And so there are 100 degrees between freezing and boiling, and that's also true of Kelvin, although the baseline is 273 and 373. So to convert Kelvin to Celsius, all you have to do is add 273.15 degrees. So Kelvin just equals Celsius plus 273.15. Pretty simple. It gets a little more complicated when you're going from Fahrenheit to centigrade. First of all, you have to change this 180 to 100, 180 degree scale to 100 degree scale. So you multiply the Celsius by 9 fifths. So you start out in a 100 degree scale, you multiply by 9 fifths to get a 180 degree scale. Then you have to move it up 32 degrees because of the differences in the baseline. So Fahrenheit equals 9 fifths Celsius plus 32. To go the other way, you have to subtract the 32 to get it on a 0 scale, and then multiply by 100 over 180, which is 5 over 9. You'll need to memorize these three formulas. They're pretty straightforward and pretty easy to memorize. And we're going to finish up today doing 3 conversions as practice, and this is one thing that you're going to have to do. So let's take a look at the first problem. You want to convert 22.4 degrees centigrade to Fahrenheit. So let's see how we would do that. So you have 22.4 degrees centigrade. You want to go to Fahrenheit. Okay? So to go centigrade to Fahrenheit, you're going to 100 scale to 180 scale. So you're going to go 22.4 times 9 fifths, which is 180 over 100. But then you also have to correct for that 32 degrees change in baseline. And that gives you the answer to the first one. And I don't have my calculator here, so I'm not going to do the calculation here, but you can do that on a calculator when you get a chance. The second question here is 22.4 degrees Fahrenheit to Kelvin. Well, 22.4 degrees centigrade to Kelvin. You'll remember that the conversion from centigrade to Kelvin, all you do is add 273.15 degrees. And then you get your answer. And then lastly, you convert 22.4 degrees Fahrenheit to Kelvin. Now there's no direct conversion from Fahrenheit to Kelvin. So in order to do that, you're going to have to convert this Fahrenheit first to centigrade and then convert this centigrade to Kelvin. So it's going to be 22.4 degrees Fahrenheit. You're going to have to subtract 32 and then multiply that by 5/9. You'll get that answer, and that'll be the temperature in centigrade, which is going to be some negative number. You can probably see that. Looks like about 1050/9. So that's going to be about, let's just say, -6. And then you're going to add 273.15. So this is going to be about 266.15 approximately degrees Kelvin. Now I can do this one in my head too. It's not too bad. It's going to be 295.55 degrees Kelvin. Shoot, I'm showing off here. Let's see if I can do this one. You divide this into this, you're going to get 20 divided by 5 is 4. And then you have 24 left over, so that's 4.6. 9 times that is 54. 5 is 41. Plus 32 is going to be 73.4 degrees Fahrenheit. So there you have the 3 answers. So that ends our work today. Bring to class on the 11th any questions you have about the problems you've worked. We'll probably talk a little bit more about significant figures because I've found that some students have a little bit more problem with significant figures. And that'll be it. Have a nice weekend.